Good afternoon, students. I am Pankaj Gupta from ABS Engineering College. In this lecture, I will discuss about the various types of lightning protection schemes. In the previous lectures, which I have completed under this unit, that is the electrical installation. So far, I have discussed about switch fuse unit in my lecture 1, miniature circuit breaker, that is MCB, in lecture 2, earth leakage circuit breaker, ELCB, in lecture 3, air blast circuit breaker, ABCCB, in the lecture 4, earthing in lecture 5, cables and wires in lecture 6, bus bar arrangement in lecture number 7. Now in this lecture number 8, we will discuss about the lightning protection. Now lightning is a giant spark of electricity in the atmosphere between the clouds, the air and the ground. Acts, Air acts as an insulator between the positive and negative charges in the cloud and between the cloud and the ground. A lightning protection system consists of 5 critical elements. Every lightning protection system will include a roof network, down conductors, equipotential bounding, a grounding system, and a surge suppression devices on incoming power and communication lines. Now we know lightning is very dangerous for anybody. If a particular building is not protected, means if there is no protection scheme available, not applied to that, the building once the lightning strikes the building will get damaged. Also, a person standing on the ground anywhere, if he's struck by lightning, the person may die, or he may face death. So it's very important that lightning protection is provided to each and every building. And most importantly, should be in each and every building that should be protected against lightning, because lightning always takes the highest point, the highest point. Lightning generates a lot of electricity. It's basically a high voltage, very high voltage, and a high value of current. There are certain schemes, very lightning projection methods. Yeah, there are schemes which are available, which are in practically are put in practice. Say building any Bhaskar buildings. It is usually buildings. Now first is lightning rod protection scheme. In this, here if you see in the diagram, this is a building and there is a lightning rod at the highest point of the building, whichever is the point. From there, a wire is laid down, maybe a wire, maybe an aluminum strip, can be anything, but it should be a low resistance. It should consist of low resistance. So here a wire is grounded to a ground rod. So a lightning rod or lightning conductor is a metal rod mounted on a structure and protect the structure from lightning strike. If lightning hits the structure, it is most likely to strike the rod and be conducted to the ground through a wire rather than passing through the structure. If the rod is not here, then if the lightning strike, the building will get damaged, where it could start a fire or cause electrocution. Persons in the building may get electrocuted, or the building may catch fire, because here the voltage level is very, very, very high. Lightning rods are also called funnels, air terminals, or strike termination devices. They are made up of conductive materials such as copper, aluminium. Copper and its alloys are the most common materials used in lightning protection. So lightning protection is a very simple method and it can be applied to a low where the height is not a matter of concern, but it's an important part of lightning protection scheme. One of the most important, effective lightning protection scheme. Next is mesh cage. Now here we are seeing that the building, this is a building, it has been covered by a mesh gauge. Mesh gauge is a nothing but it consists of a mesh used across the covering of the roofs and side walls of the structure. All these red lines and all are grounded. If you can clearly see that all are grounded. It is used for highly exposed buildings, housings, where sensitive installations such as computer rooms, all and where we have got documents kept. All those rooms are under mesh cage. Now this mesh is of also again consists of metals made up of a metal which is having a low resistance. Next is the third scheme is Faraday's gauge. Now a Faraday's gauge is a protective enclosure device made up of conducting materials that can protect against lightning strikes and other electromagnetic fields. The cage works by distributing the electric charges of a lightning strike through the cage, preventing them from penetrating the enclosed area. Now, here if you see, a person is enclosed in the cage, and in case, and here I'm representing this lighting with the source of a high voltage. Now, if it's made to pass through this cage, what will happen? The metal will get ionized, and all the charges, all the current will be conducted through these metal parts. And since this cage is grounded, then all the lightning means the current will pass through this ground. So the person in the enclosure, yeah, in the cage, will be saved. It distributes the electrical charges of a lightning strike around the cage, preventing them from penetrating the enclosed area. The person is saved because of this. Now, in the earlier three schemes which we have earlier discussed, they were dealt for a particular building, particular area. But now we will discuss about two systems where a community is prevented from lightning protection. Maybe a block of household block, a colony. So these types of protections are used. So the first one is dissipation area system. A dissipation area system is a lightning protection system that uses a metallic hemisphere umbrella to prevent lightning strike. The DS is made up of thousands of metal needles that ionize the air above the umbrella. Here we have seen this is the charge cloud, this is the natural space charge, concentrated space charge. Now once the charge enters this distributed area and another, it is concentrated and it is passed to this tower. So the area under this curve, this is the umbrella, is saved. And here also this is distributed. The charge once it comes enters this tower, this area is protected. The ground acts as a collector and it serves as a service wire. But the area is protected because of this umbrella. Because of this umbrella. And all the charges and currents or same thing are passed through this tower into the surface wire and ground. Everything is neutralized and the household, or you can say here we are not applying the system into the highest point of the building. Here we are trying to save this around the surface area. So in this case, this can be applied for a large amount of area, maybe in a colony, maybe in a area. Many people live on. So instead of building, we are having a building outside. Means In case of Faraday's cage, or we can have mesh cage. Here in this case, we are having a surface area. A large surface is protected only on account of this dissipation area. Next is charge transfer system. A charge transfer system is a system intended to prevent a lightning strike from occurring within a protected zone or area. Here again, it is similar to DAS, but here there is an air gap. The CTS collects the induced charges developed by the thunderstorm clouds and from a designated protected area on the earth and transfers this charge through the ionizer into the surrounding area. This is the ground. This is the variable impedance unit, electrically floating dome, air gap, and the grounded rod. Here, this grounded rod is grounded. Once the lightning strikes, it's struck on this dome and then it onto this air gap. So here we have positive, there we have negative, due to which the current will flow into the dome. So we have got three conventional and two non-conventional types of sources, protection schemes. First three are conventional, the last two are your DAS and CTS are your non-conventional protective. These are the references which we have used for the diagrams. This is only for teaching and education purposes. I would like to clarify, this is only for teaching and education. Thank you, students.